are going to go over lesson 22, which is analyzing continuous, discontinuous, and discrete functions. Your first thing to figure out, well, is it a function? If we were to take a look at this one, that is obviously not a function because it doesn't pass the vertical line test. Alright, so that is not a function, but if we come over here, that would be a function because it does pass the vertical line test through there. Alright, if it does pass the vertical line test, it is a function. So then we have to figure out, is it continuous, discontinuous, or discrete? Well, easiest rule for continuous is, can you draw the entire graph without lifting your pen off the paper? Well, this one, absolutely. As you draw here, you can draw that entire thing without taking your pen off the paper. That makes it continuous. Even with this one over here, we can draw that entire graph without lifting your pen off the paper. Problem is though, is that is not a function, so then you can't say it's a continuous function. Alright, so continuous, you can draw the entire thing without lifting your pen off the paper. Discontinuous would then mean, well, can you draw the entire graph when you draw the entire graph, you have to take your pen off the paper. As you're going across on this one, we're coming across, we still haven't taken our pen off the paper. Oh, this open circle means this point does not work. And then after the point, then it starts to work again. Because of this open circle here, this one is discontinuous now. Alright, so discontinuous, you can't draw the whole thing. Another example of discontinuous would be like the following here. Say I have that and this. First of all, that is a function because it does pass the vertical line test. Alright, it's not continuous because we've got this big gap in between there, but it is discontinuous, isn't it? There's an open circle there, we jump down here, and then it continues from there. Alright, so that's continuous and discontinuous. A discrete function is just a whole bunch of points that passes the vertical line test. Alright, so for example, that. It passes our vertical line test, so it is a function, but it's just points, so it is discrete. For our next one, we need to graph each one of these functions and then state domain and range of the function. Well, we've got a discrete function here, first of all, which is important to know, and then it looks like we just have 4 points here. So we need to graph the points, so -7, 1, -4, 3, -1, 5, and 4, 7. Now, we've got those points graphed. Now what we are going to be tempted to do is to draw in a line there to connect those points. We don't do that though because it does say discrete there. Discrete is just putting the points on the graph. So that is the graph without a line stating the domain. Well, the domain is simply the x values. Say -7, -4, -1, and +4. Alright, our range are the y values, 1, 3, 5, and 7. Okay, for our next one, the continuous function, continuous meaning it's going to be some kind of line where we don't lift our pen off the paper. We've got a linear equation here, so we can do slope-intercept form. So we go up 4, put a dot, and then go down 2 over 1 for our slope, and then we draw in our line. There's our line, there it is graphed. Then we need to state what the domain and range are. Well, remember, domain is what are all the numbers for x that are going to work here. Well, if we look, 1 works, 2 works, 3 works, 4 works, and so on. It's going to continue going to the right as it goes down. Well, 0 works, -1 works, -2 works. As this thing goes up, it's also gonna continue. So for this one, it is all real numbers. Alright, for our range. Range is talking about our y values here. What are all the y values that work? Well, 0 works, 1 works, 2 works. Everything as this line keeps going up, so does the y. As this goes down, all the y values are going to work for that also. So this one is all reals also. Is that always the case for every line out there? No, it's not. So you do have to check as you go here. Alright, next one, determine if each graph is continuous, discontinuous, or discrete. Determine if it's a function or a relation. Determine the domain and range of each of them. So let's say that we had this function. Alright, first of all, we gotta check and see, is it a function? Alright, as we go across, yep, that passes the vertical line test, so it's a function. Is it continuous? Well, no, because we've got this open circle here. Is it discontinuous? Yes, it's discontinuous. Is it a function or a relation? We already did the vertical line test, so it is a function. Determine the domain and range of this. So what are all of the x values that work? Well, say we start right here and we go to the left. Alright, -1 works, -2 works. All of these work as far as our negative numbers go. As we're coming on the positive, well, everything, it works all the way up to 2. Then once it gets past 2, then it starts working again. So for our domain, it is all of the x values except 2 are the ones that work. For our range, well, let's take a look. Range is y values. So as we're going here, our lowest point is at this 2 value. There's nothing lower. Does everything above 2 work? Yeah, everything above 2 works. Even this 7 here, even though there's an open circle here, 7 works there, and there, and there, and over here, and way over there also. So we can say y is greater than or equal to 2 for our range. If the question was, name all of the points where x is discontinuous, then we would take and look for these open circles. Well, the only place where it is open is when x equals 2. So that's all you would have to say for that question if you get asked that question. All right, any questions, please let us know.